We're now ready to combine the four gas laws that we've worked on into one single overarching ideal gas law. To refresh our memories, here's the four laws: Boyle's law, Charles, Avogadro, and Gay-Lussac. You can combine those, and a cool thing to do, you check out Wikipedia, look up ideal gas law, and it actually shows you how to take these various equations and come up with right over here. This is the ideal gas law. PV over NT, N's the number of moles, equals a constant, which is some combination of these guys here. You then just multiply it out, make it all on one line. PV equals nRT. R is the gas constant. This is the only formula you will need for ideal gas problems. We have to be careful now. Earlier we said we didn't care what units you used in pressure because they would cancel out, but here we do have an issue. The value of the ideal gas constant, R, will depend on the units chosen for the pressure and volume. We already know the temperature always has to be in Kelvin, but now for the ideal gas constant we have a couple choices here. And if we use the units of liters times atmosphere divided by moles, Kelvin, this is the value of R. Put a big R there. If we're using joules and moles and Kelvin, it's 8.314. Now this is more commonly used in physics. They're a little more adherent to the SI units. However, in chemistry here, when we solve problems, you can see this is important because it says it's important and it's in bold. We will only use the gas constant that has these units here: liters, atmospheres per moles, Kelvin. Therefore, when we do problems, all pressures have to be in atmospheres and all volumes have to be in liters. Let's lay out a process for working with the ideal gas law. So let's start. We're going to give a particular state of a gas by giving its pressure, temperature, volume, and number of moles. If any three are known for a gas sample, the fourth can be calculated using the ideal gas law. So here's our problem. What is the temperature in Kelvin of 32 grams of nitrogen gas that occupies 200 milliliters at a pressure of 450 milligrams of mercury? First, write down the known variables. Again, make sure V is in liters and pressure is in atmospheres. You have to convert grams to moles, and we did that in the last unit quite a bit. Temperature, of course, has to be in Kelvin. Rearrange the ideal gas law, PV equals nRT, to solve for the unknown variable, and then finally at the end you put the numbers in and solve. Question: what is the temperature of 32 grams of nitrogen gas that occupies 200 milliliters at a pressure of 450 millimeters of mercury? So you write down the known variables and do the conversions right up front. We go from milliliters to liters, because we have to be in liters for the volume. We have to be in atmospheres, so we know that 1 atmosphere is 760 millimeters per mercury. And then we go back to our old friend molar mass to figure out how many moles of nitrogen gas we have. Well, we know nitrogen, we go to the periodic table, has an atomic mass of 14. So the molar mass there would be 14 grams. You have 2 nitrogens, that's 28 grams. That's the molar mass of N2. We have 32 grams of it, so that works out to be 1.1 moles of nitrogen. Now rearrange the ideal gas law to solve for the unknown variable. Well, the unknown variable is temperature. So we start here, divide by NR, and we get this. So hopefully you can see the value of solving from the unknown variable, because we now have 4 different numbers to plug in, so it makes it a lot easier if they're all on the same side. The last step is just plugging in the numbers. Okay, so you've done all the hard work on the previous slide. You did all the conversions, you isolated the variable, and you just plug them all in. And notice the value of R we're using. That's the only one we're going to deal with. And then we come up with a temperature of 1.3 Kelvin. Yeah, that is cold because absolute zero is just 1.3 Kelvin away from that. The other value of solving for the unknown like this is once I have it in this format, I can change the numbers however I want and quickly come up with a new temperature. I might say, all right, Now you have a volume of 400 milliliters. What's the answer? And I just swap out the 200 and put a 400 in there.